Now in question number 131, they have given this circuit and we have to find the current in 5 ohm. Okay. Now the main current, the total current which will divide here is given as 2.1 ampere. This is a Wheatstone bridge, right? So first we have to check is balanced or not. So if you look carefully, P by Q is 8 by 2, which is 4, and R by S, right? This is P and this is Q, and this is R, this is S. 20 by 5 is 4. So it is balanced. And once it is balanced, no current will flow here. So this branch will be useless. So you can remove this branch. So no current will flow here, right? So now this current will divide here I1, I2. So in the question we have to find here current. So we have to find I2. So here you can use branch rule, isn't it? You can first convert this into two resistors in parallel. 8 and 2 will give 10 ohm in series, 20 and 5 will give 25. These two are in series. So now I1 current here, remember I2, right? I2 will flow this way, right? So I2 will flow here. So how to find I2? Resistance of opposite branch divided by total resistance into the total current. That will come 10 by 35 into 2.1. 5 2s are 5 7s are 31, 7.3s are 21, so 0.6 ampere. Okay. So this branch rule is very important. Okay. So whenever you have two resistance in parallel, current in one branch will be resistance of opposite branch divided by sum of the resistances into the main current. Okay. So now let us see question number 134. So they have given a meter bridge. They told the resistance in the right gap. This is the right gap of the meter bridge. This is the left gap of the meter bridge. So on the right gap they have kept 1 ohm resistance, and this will become your unknown resistance. Unknown. Let me write X. And as you know, you have to slide this pointer, which is jockey, along the bridge wire, and at some length the galvanometer will not show any deflection. That means the circuit is balanced. So in that case what happens? P by Q. This is like your P, this is like your Q. So resistance of left gap by resistance of right gap will be equal to R by S. Now R means resistance of this, which is rho L by A, divided by resistance of the remaining part will be rho L. L of this part will be how much? 100 minus L, because this whole thing is 100 centimeter. So if this length is L centimeter, L in centimeter, remaining length will be 100 minus L centimeter. Okay. And what happened to rho L by A? Rho L by A, rho and A will cancel. So this is the formula for meter bridge problems. So here resistance of left gap by resistance of right gap is L by 100 minus L. In the left gap, what is the resistance? Unknown resistance. On the right gap, it is 1 ohm resistance. Balance length is 20 centimeter. 100 minus 20 will be 80 centimeter. Centimeter cancel. So X will be 1 by 4 ohm, which is 0.25 ohm, isn't it? Okay, now in the question number 134, they have given a meter bridge wire, and they told in the first case the balance length from the left end of the wire is found to be 20 centimeter. Okay, the resistance on the left gap and right gap is not given, so I assumed R1, R2. So with this given data, what equation can you write? Resistance on left gap by resistance on right gap is what formula? L by 100 minus L. So here length is given 20 centimeters, isn't it? So we will get R1 by R2 is equals to 20 by 80, which is 1 by 4, isn't it? 20 by 80, 1 by 4. So clearly, who is the smaller resistance? R1 is the smaller resistance. because if you cross multiply, R2 is 4 times R1. So R1 is smaller. Now in second case what they told, when resistance of 15 ohm is connected in series with the smaller resistance. From here we came to know R1 is the smaller resistance. So there they are connecting another resistance in series which is 15 ohm. So now the balance point shifts to 40 centimeter. So from 20 centimeter it will shift because this resistance became slightly more, right? Before it was R1, now it is R1 plus 15. So if this resistance increases, this balance length will also increase. So now it is 40 centimeter. So for case 2, this is equation 1. For case 2, what will be the equation? Resistance on left gap R1 plus 15 by resistance on right gap is same only, right? Will be equals to L. What is L now? 40 centimeter by 100 minus 40. This will give you R1 plus 15 by R2 equals to, this will be 60, 2 by 3, isn't it? So this is your equation 2. So now obviously we can solve equation 1 and 2. So we have supposed to find the smaller resistance R1. So if you cross multiply, R2 will be 4R1. Substitute here. What will you get? R1 plus 15 divided by R2 is 4R1 equals to 2 by 3. Cross multiply. Here 3R1 plus 45 equals to 8R1. Take 3R1 that side. So 45 equals to 8 minus 3, 5. This will be R1. So therefore R1 will be 45 by 5, which is 9 ohm. Right? So next question 135. It says resistance on the left and the right gap of a meter bridge is given 10 ohm and 30 ohm. If they are interchanged, okay, so left resistance is taken to the right and right resistance is taken to the left, by how much the balance point will shift. So initially, what was the balancing length? Let us try to find. R in the left is 10, R in the right is 30, and that is L by 100 minus L formula, right? Resistance in left gap by resistance in right gap is L by 100 minus L. So 0 gets cancelled, cross multiply, 3L will be 100 minus L, 4L will be 100, so L will be 25 centimeter. So if this is your bridge wire and your galvanometer is coming like this, then right now the balance length is 25 centimeter. So this is your balance point. Now they are interchanged. So if you interchange, this will be now resistance in the left gap and the resistance in the right gap will be 10 ulta. So this will be L dash by 100 minus L dash. New balance length will come. So this is after interchanging resistance in the left gap and right gap. So now if you again simplify, 300 minus 3 L dash will be L dash. So this will be 4 L dash. So L dash will be 300 by 4. So that will give you 2 2s are 4, 2 1s are 2 5s are, then 2 75s are. So now the balance length is coming 75 centimeter. So this is the shift, isn't it? So how much the balance point shifted? From 25 it went up to 75. So 75 minus 25, which is 50 centimeter. Right? So the answer is 50 centimeter. So next question 137. So they have given this circuit and here is a cell with EMF E, internal resistance is given 4 ohm, and they want maximum power, to get maximum power delivered to the circuit. So to deliver maximum power to this circuit, what should be the value of capital R? First understand that this is a Wheatstone bridge. How? Well, look carefully. These two resistors are in series, right? No junction is there in the middle, so same current will flow. So since these two are in series, we can replace these two by R, and R in series will be 2R, isn't it? And this R and this R are also in series, so this can be replaced by again 2R. Now if you think carefully, if I call this point as A and B, so between A and B you have this 6R, and if I call this C and this as D, then between A and C we have this R, and between C and B we have 2R, between A and D we have 2R, and between D and B we have 4R, and this battery is between C and D, right? Which is EMF is E, internal resistance is 4 ohm. So this circuit is actually this circuit. So now check whether this circuit is balanced or not. P by Q. Here it is R, here it is 2R. So P by Q is half. R by S is how much? 2R by 4R. That is also half. So the circuit is balanced. And if it is balanced, no current will flow in the middle branch, so that will be useless. So now this resistance will be 3R in series, and this will be 6R, isn't it? And that 3R and this 6R are in parallel. So the external resistance, the total external resistance will be R1, R2 divided by R1 plus R2. That is the formula for equivalent resistance in parallel. R1, R2 in parallel. R1, R2 by R1 plus R2. You can also use 1 by R1 plus 1 by R2, and then you take reciprocal, ulta. So here it will be 18R square by, this is 6, right? 9R. That will give you 2R. So external resistance is 2R. Now, because they told maximum power should be transferred, we will use maximum power transfer theorem. And that transfer theorem says, maximum transfer power theorem says that for power to be transferred, maximum power to be transferred, external resistance should be equal to internal resistance. Here what is external resistance? 2R. Internal resistance is given as 4 ohm for the battery. So from here capital R will be 2 ohm, right? That is the answer. So now let us see question number 181. This question is based on meter bridge, and if you see the resistance on the left gap and the right gap is same, R dash, R dash. And the bridge wire, usually the bridge wire is uniform, the area of cross section will be same. But here the bridge wire is non-uniform. The area increases as we go this side. And they have mentioned that the bridge wire is non-uniform, and therefore its resistance changes with length as you move this side according to this formula. So this is the change in resistance with length, which is proportional to 1 by square root of the length which you have travelled. They want the balance length AP. This balance length they want when galvanometer will show no deflection. Now, if the galvanometer is not showing deflection, it means the circuit is balanced, and for balanced condition, the resistance of this left gap by resistance of right gap will be equals to resistance of this part divided by resistance of this part. If I call this point B, then resistance of the part AP divided by resistance of the part PB. Okay, so this is your balance condition, P by Q equal to R by S. Remember, you can't write L by 100 minus L now. because this resistance cannot be written rho L by A. Before we wrote rho L by A, rho 100 minus L by A, and we cancelled A because it was uniform wire. Now the wire is not uniform, right? So we cannot use L by 100 minus L. Then what to do? So let us, this by the way will cancel. So resistance of this part AP must be equal to resistance of the part PB. Now already here they have given you how resistance varies with length. So here if I write this formula equal to some constant K, then if I cross multiply, what will be dr? K dl by root L. So this R is resistance from A to P, and remember this L is measured from here, okay, from the left end. So this resistance can be written integral of dr, resistance of a small part, from 0 up to here, and this is the balance length which we have to try to find. So let us write this as L equal to remaining resistance will be what? Integral of dl from L to up to this point will be 1, isn't it? Because this length is 1 meter. So when you are here, the distance from the left end is L. When you reach here, the distance is 1. So this resistance is from here to here. So when you are here, it is L. When you are here, it is 1. And this resistance is from here to here. When you are here, length is 0. When you are here, length is L. So this will be K dl by under root L 0 to L integral K dl by under root L to 1 meter. K constant will cancel. Now what is integration of 1 by root x dx? Integration of 1 by root x dx, that is x power minus half dx, which is x power n plus 1 divided by n plus 1, which is x power half by half, which is 2 root x. Okay, so this basic integration you must know. So this is 2 root L upper limit L lower limit 0. This is also 2 root L upper limit 1 lower limit L, right? So if you put upper limit, you will get 2 root L minus 0, here 2 root 1 minus 2 root L. So bring this 2 root L here, so it will be 2 root L plus 2 root L is equals to 2 root 1 is 2 itself. So this will give you 4 root L equals to 2. So root L will be 2 by 4. So L, this is 1 by 2. So square will be 1 by 4. So balance length is 1 by 4 meter, right? Which will be 0.25 meter, isn't it? So let's see the next question. Question number 180. Again, they have given you a meter bridge circuit. The resistance on the left gap is R here and resistance on the right gap is S. In the first case, they have given you the resistances and the length, the balance length from A is given as 42 centimeter. And when the resistances are interchanged, the balance point is now at 57 centimeter. They want you to find end corrections at A and B. So I told you, when this wire is tied on the screw, a small part will be on that screw itself, right? And the resistance of that length is not considered in the formula. R of the left gap divided by R of the right gap is equals to L by 100 minus L. So in that formula, we have not included that end correction. But here we have to consider end correction. So the formula will be resistance of left gap by resistance of right gap is equals to L plus end correction at A divided by 100 minus L plus end correction at B. So this formula we must use. Okay. Now in the first case, resistance on the left gap is R, which is 15, and on the right gap is S, which is 20. balance length is 42 plus x divided by 100 minus 42. What is 100 minus 42? 10 minus 2, 8, 9 minus 4, 5. 58 plus y. So this will be 5 3s are 5 4s are. So if you simplify, you will get 4 2s are 8, 4 4s are 16, 168 plus 4x equals to 3 8s are 24, 4 2 carry, 3 5s are 15, 174 plus 3y. So now if I bring this 3y this side, I will get 4x minus 3y is equal to 168 that side. So 174 minus 168, 1 carry 14 minus 8, 6. So this is your equation 1. Now you need one more equation to solve for x and y, which are your end corrections, remember. Now in the second case they told the resistances are interchanged, right? So now the resistance on the left gap will be 20, on the right gap will be 15, right? Before it was 15 by 20, now 20 by 5. Now the balance point is at 57 centimeters. So 57 plus x divided by 100 minus 57 will be 43 plus y, isn't it? So again this will be 5 4s are 5 3s are. So now if you cross multiply, 4 3s are 12, 2 1 carry, 4 4s are 16, 17 plus 4y, right? 4 into this, and now 3 7s are 21, 1 2 carry, 3 5s are 15, 16 17. So 171 plus 3 into x, 3x. So now this will give me, if I take 4y this side, 171 this side, I will get 1 is equals to 3x minus 4y. Or I can write 3x minus 4y is equals to 1. So this is my equation 2. So here is equation 1 and here is equation 2. To solve this, I will multiply this with 3, I will multiply this with 4. So equation 1 into 3 will give you 3 4s are 12x minus 9y equal to 3 6 are 18. Then I will multiply equation 2 with 4. So 4 3s are 12x, 4 4s are 16y, 4 1s are 4. Then subtract. These two will cancel. So 16y minus 9y will be 7y is equals to 18 minus 4 will be 14. So y will be 2. And if you put y2 in equation 2, so in equation 2 if you substitute, you will get 3x minus 4 into 2, 8 equal to 1. So 3x will be 9, right? Minus 8 will go there. 8 plus 1, 9. So x will be 3. So the end corrections are 2 centimeter and 3 centimeter, right? Let us now see the next question, question number 182. They have given a Wheatstone bridge network, except instead of resistors here we have capacitors, and they want you to find balance condition. Now balance condition means no current should flow in this branch. That means potential of this point VB should be equal to potential of this point VD. So if no current flows here, then this can be removed, isn't it? Now whatever current came from here will divide like this, and this will get charged, plus Q minus Q, and that current will make this also charged, plus Q minus Q. You can see these two are in series once there is no current flow in this branch. So if these are in series, charge must be same, right? Now current here will flow, I let's say. Remember, once these capacitors are fully charged, no current will flow here. Okay, so we are talking about steady state. Steady state means when the capacitors are fully charged. So no current will come in this branch also. So now they told they want balance condition. Now balance condition means potential of this and this should be same, remember. So now I can write potential between A and B, VA minus VB, equals to Ohm's law for this resistor I into R1. Similarly, potential between B and C, VB minus VC, I can write I into R2. Correct? So these are my Ohm's law applied to these resistors. Okay? Similarly, potential difference between A and D, VA minus VB, will be equal to, for capacitor don't write I into R, for capacitor potential difference is Q by C, right? The charge on positive plate divided by capacitance, which is C1. And here what will be potential difference? VD minus VC. That will be Q by C2. So these are my 4 equations, right? Now for balance condition, VB should be equal to VD. So this VB should be equal to this VD. So from equation 1 and 3, we notice that left side VA, here VB and VD are same under balance condition. So left sides are same, so right side should be same. So IR1 should be Q by C1. Similarly, from equation 2 and 4, we know VB is equal to VD and here minus VC minus VC. So from 2 and 4, left sides are same, so right side should be same. So IR2 will be Q by C2. So these two equations should be satisfied if the circuit is balanced, which means the ratio also should be satisfied. So if you take the ratio of this equation, I will cancel, Q will cancel. So I will get R1 by R2 will be equal to C2 will go up, C2 by C1. So if capacitors are there, the condition is R1 by R2 is equal to, not C1 by C2, okay? R1 by R2 is equal to C2 by C1, ulta, okay? Now, before we do the next question, try to understand this simple concept. Imagine we have this circuit which is like a Wheatstone bridge, right? P, Q, R, S, and galvanometer will be here, okay? But I will not connect the galvanometer right now. Now some current is coming from here and that divides, let's say. Okay, so let's say current is here 10 ampere. Now I want to ask you whether this potential is higher than this potential or this potential is higher than this potential. How to decide? So for simplicity, I have taken here 1 ohm, 1 ohm and here 2 ohm, 3 ohm. So this is like your P, Q, R, S, right? This is like your P, this is Q, this is R, and this is S. So now here, what is P by Q? 2 by 1. And what is R by S? 3 by 1. So which is greater here? Of course, P by Q is less, right, than R by S. So P by Q is less than R by S. Remember this. Now, this current 10 ampere will divide here. Okay. So how to find these two currents? We can use branch rule. So current in the upper branch will be resistance of the lower branch, which is 4, divided by sum of resistance, which is 4 plus this resistance is 3 into the main current, which is 10. So 40 by 7 amperes. That is the current here. What is the current in the lower branch? Resistance of upper branch 3 by total resistance 3 plus 4, 7 into the main current, 30 by 7 ampere, right? Now let me find potential difference between A and B, VA minus VB, here potential difference. So I can use Ohm's law here, current into this resistance, and current here I1 is 40 by 7, so it will be 80 by 7. This is VA minus VB. Similarly, let me find potential difference between point A and point D. So VA minus VD will be Ohm's law. Here you apply I2 into R. What is R of this resistance? 3. Current I2 was 30 by 7, so this will be 90 by 7. So this is VA minus VB, this is VA minus VD. Now I know this is bigger than this, so let me subtract this equation and this equation. So equation 2 minus 1. What will I get? Equation 2 is VA minus VD. Equation 1 is VA minus VB. Subtract means this will become minus VA, this will become plus VB. And this will be 90 by 7 minus 80 by 7, 10 by 7. You can see VA minus VB, VA minus VA cancels. So you will get VB minus VD, VB minus VB is equals to 10 by 7, which is nothing but potential difference between B and D. So try to remember that if P by Q is less than R by S, let me mention here, if P by Q is less than R by S, it means potential of B is greater than potential of D, isn't it? Because this difference is a positive number, so VB should be greater, which means if I connect a galvanometer, current will flow down. Down means from B to D. Okay, so here current will flow from, current in galvanometer will be from B to D. And the other one will be what? If P by Q is greater than R by S, then VB will be less than VD. Current will now go up. Okay. Now next question is actually from level 1, question number 58. But it's a very interesting question. So they have again given you a meter bridge circuit, and here are your resistance R and S, and this point D is your neutral point. Neutral point means balance point. So right now this divided by this, so this is like your P, this is like your Q, remember, okay, this is like your P, this is like your Q, and this is like your R, and this is like your S. So right now P by Q, which is R by S, is equal to this L divided by 100 minus L, right? Okay. Now they are saying if this jockey is moved this side, right side, okay, so if jockey is moved towards right, this side, then what will happen? This length will become more than the balance length, so this will increase. Now that means in our formula, remember this is P and this is Q in our old formula, so P by Q. Now this P and Q are fixed, but when you move this side, this L will increase, so this resistance which was S, right, so that will increase. So P by Q will become less than R by S, because by moving this side, this L will increase, so R will increase. So just now I told if P by Q is less than R by S, then current will flow from B to D or D to B. So if you check, you will see that if P by Q is less than R by S, current comes down. Okay, so current flows in galvanometer from B to the wire at D. Okay, so option C will be correct. What if you move the jockey to the left? Then this L will become less than the balance length. So P by Q will be greater than R by S. Then current will go up. Remember, up means what? From wire to B. Wire to B means up. B to wire means down, right?